Okay, so here's the problem most humanoid models have using the usual single bones arm armature.
Disgusting!
This is disgusting. This is awful in every way.
So this video is gonna be like a little experiment. I'm not even sure this is gonna work, let alone get a good result, but it should be an interesting exercise anyway. Okay, so this is my model. Oh, I better censor this. Nah, I'm just kidding, there's nothing there. As smooth as my brain. So this is my VTuber model. So just to show you guys, the weight painting it's nothing special. So here's the arm, the lower arm, and the wrist. So why does this problem happen? Well, basically when I twist this, all of the twist happens right here in the wrist, right? And when I twist this bone here, all of the twist happens in the elbow. So basically there's no way around this. I either twist over here or I twist over here, and the result is always just terrible. So if you take a look at your arm and just rotate your wrist left and right and just look at what happens, right? You're gonna notice that your arm barely rotates around the elbow, and it's like a gradient, right? As it gets closest to the wrist, the arm starts twisting more and more, and so the twist is basically distributed all along the arm. And the way that the body does this is really interesting. So actually we have two bones over here, not just one, right? That's why those usual armatures don't really work, because they're trying to do the work of two bones in just one, right? So what happens here is basically those bones kind of stay where they are here in this side, but in this side they kind of turn over and cross each other when you turn your arm. So something like this. So here, of course, I'm just using deformations to kind of show what happens, right? So the bone doesn't really bend like that, but they kind of just move the two pieces in this way. And that's how the twist is distributed on the whole arm instead of like just the wrist. Isn't that cool? Science, bitch! Now the usual solution for this in 3D models is like they get this bone here and they cut it in three pieces like this, so that basically each one of these pieces rotates a little bit and distributes the deformation, right? But I wanted to attempt something different. I want to see what happens if I kind of do the same thing that happens in the real body, right? So instead of using just this one bone, make two bones side by side that twist around each other, and see if this creates a good deformation on a 3D model or not. So that's it, let's see how this goes. Okay, so first I'm going to go into edit mode here, and I'm going to select this elbow here and add two more bones like this, 1 and 2. Move them back a little. Okay, now I'm going to select this wrist joint here, and I'm going to create two more bones from here like this and try to make them the same size. Now I'm going to select this and snap them over here, and to do this I can click this and put the cursor over here, and then just do a snap selection to cursor over here and do the same on the other side. Alright, so now I have these two extra bones. I'm gonna rename them like this: upper arm radius L and ulna L. And I'll rename these two as well. I'll just add target here, ulna target L, and radius target L. So basically I want these bones to move with the wrist and these bones to point at this. So these bones will basically be the targets for these bones to move correctly. Okay, I'm gonna do some weights painting now. And what I want to do is take the weights from this bone and transfer it to these other two bones. So I'm gonna go into a weight painting mode here. Also, I want these two bones to have more or less the same influence over the whole arm. So instead of setting the weights automatically, I'm gonna do something a little different. I'm gonna first lock everything, lock every bone, then I'll unlock only these three. And now I'll simply select this bone and paint it black, or weight 0. And hopefully the weights are gonna be transferred into these two, because they are closest to this bone, and also because every other bone is locked right now. So let's just paint this. Alright, so now this bone has 0 weights, and these other two are pretty much the same, half and half influence. Alright, so now I'll unlock everything because it doesn't matter anymore. Okay, now I want to add some constraints so these bones move the way I want them to. First, I don't want this bone to influence the wrist rotations. So first I'll go to object mode and select the armature, and then go to pose mode, and then I'll select the wrist bone, go here into bone settings, and I'll untick this. Okay, now I want these two bones to rotate around this axis, which is the Z axis, and basically copy the Y rotation from this bone here. And before I do that, I have to set the roll from these bones, so they rotate around the axis that I want. So let's go to edit mode. I'll click here on data. On viewport display, I'll select this so that I can see the axis of the bones. I want Z to be pointing this way. So I'll select this bone here and then rotate this roll here until Z is pointing this way. There we go. And this bone, I want it to point this way. So let's do the same. Alright, there we go. Okay, so let's go to pose mode now. So if I select this and I'll switch this mode here to Euler YZX. So if I rotate this Y clockwise right here, it goes into the negatives, right? And I want the same to happen here in the Z. So let's move this into Euler as well, and also for this one. And let's rotate this on Z clockwise. So Z goes into the negatives over here, and on this other bone, it goes into the positive. So we'll select this, right click here on Z, add driver, we'll open the driver editor. In the variable here, we'll select the armature, and the bone is the wrist. And then I want to copy the Y rotation in the YZX Euler in local space to Z. So let's see if this works. Now the wrist is moving together with that bone over there. And do the same for this driver, except for this one I want minus var, otherwise it's gonna rotate in the wrong direction. So minus var like this, and let's test. There we go, perfect. Okay, next step is to have these two bones pointing at these two bones. We just click here and add a constraint for damped track. So this constraint here makes these bones point at a target without affecting the rotation. So this is what we want. We'll select the armature and the bone, and then we want to point it to the tail, and this is pretty much it. Do the same for this one, and there we go. Now if I rotate this, it should move those two like that, see? Now when I rotate this, nothing really happens over here, and I did some tests and I figured out that I have to actually rotate these bones around their y-axis as well, otherwise nothing gets deformed. Not really sure why it works that way, but let's try it anyway. So we'll select this bone here, and we'll add a driver to the Y rotation, again in the Euler mode. Alright, so let's add a driver here. So let's try var over 2. So I want to copy half of the wrist rotation into the rotation of these two bones here. Like this. And then this is the same expression I want for this other one, so I'll just copy this driver and paste it here. So now when I rotate this, I should see... Yeah, this is working way better already. There's still some weirdness here, but I think we can improve this. And if you look here at the elbow, this is already a lot better as well. So let me just make some tests and see if I can improve this. Alright, so first thing I noticed is that I need to somehow influence the rotation of this bone here, the upper arm, with the rotation of the wrist. And the reason is, if you look at this pose here, this is the rest pose, right? So if you make this pose in real life, this is like close to the limit on one side. You can kind of turn your arm a little bit further than this, but not much. Right? And when your arm is in this position, you're gonna notice that your bicep kind of falls into this position naturally, which is the reason I made this the rest pose. But if you turn your arm like this, like straight up like this, you'll notice that your bicep is gonna rotate to point straight up as well. But in here it's still in this position. So I want to make it so that when I rotate the wrist like this rotates up as well. So I'm gonna add a driver to this bone. Add a rotation to Y, and then I'll set this var to var times 0.1. So that means whatever this rotates, this will rotate a tenth of that. And I chose the wrong wrist, it's the left wrist. Alright, I just noticed another issue. The issue is the driver flip. And what is that? Oh, basically, okay, let me reset these rotations. Okay, because this bone and this bone and this bone are rotating at fractions of this bone here. After this bone rotates 180 degrees, these other two bones are gonna rotate in the other direction, basically. They're gonna flip, right? So I can see this by rotating this like this, and there we go. You see they flip right here. And this is fine, this has to happen, right? But I don't want it to happen here. I want to be able to rotate this all the way up here before any flip happens. Okay, so after getting some help with the math, I reached this function over here, and I'll explain what this is. So this is the function that drives the Y rotation of one bone based on the Y rotation of the other bone. So this var is the wrist rotation. Before we had just var times 0.1, right? This is our function before. This is our new function, and it has a couple of more variables. So first, this 0.1 is this ratio here. Second, we have this is pi, this is just pi. And then we have this disp, which is displacement. And this is the displacement angle that we're gonna add to the flip. So whatever you put it here, the flip is gonna happen a little later. So whatever this value is gonna displace the flip point, basically. So let's try to plug this in here. We'll start playing with this bone here, the upper arm, and whatever value we find here, we'll use on the other two as well. So let's put this formula here. I'm gonna increase this so you can see the whole formula. Actually, I'm putting this in the wrong place. This is var, and the expression goes up here. Sorry about that. And ratio is 0.1, right? Okay, so let's test this. Alright, there we go. So here's where the flip is happening. Let me look from this angle here. This is okay, but I think I want a little more. So let's try 1.5. Alright, 1.5. Let's try again. There we go. This is really good. Now I'm gonna put this value in these other two bones. Now this is var over 2, so it's 0.5. So use the same formula, but 0.5 over here. The same for this one. And there we go, no flip. And we can go back here. We're still getting quite a pinching over here, so let's see if we can fix this. Alright, so this took quite a bit of tweaking with the weights and also fixing some bugs and improving some issues with the drivers. So let me show you what I did. First, these drivers here, that Euler setting was not working really well, especially when bending the wrist. So I actually switched them all to follow the swing and right twist here, and this is pretty much the perfect setting for all of them, because whatever you do with X and Z doesn't affect the Y at all. So like if I rotate this in X, it doesn't change the value of these drivers, and if I rotate this on Z as well, it doesn't change anything, right? So this was the first thing that I did, and also I tweaked a little bit the weights, and this was a lot of putting the wrists in extreme positions and then adding weights over here, removing over there, doing this blur, and just repeating this process over and over again until I got something like this. Also increased the influence of this area over here. I did some tweaking on the wrist, so now the wrist is bending pretty well. Like, let me go to pose mode real quick. Oh yeah, I also changed this driver over here to be a 0.2 ratio and these two to be 0.4 instead of 0.5. So here's the result, like this bending all the way over here, which is like pretty much the limit for human range. And the wrist is pretty good. There's a little pinching over here. And we can still improve things, like just doing this over here, and we can improve that pinching, you know. We can always tweak and make this look a little better. Like this over here, make it a little more straight. Like this curve over here is not very good, so we can like do some of this, like that, see? Way better. And this is a lot better as well. And by the way, another factor is how I model this, which is not ideal. So if you think about it, this hand is already like in an extreme position. So if I rotate it just a little bit over here, it's like at the maximum, like I don't know, 20 degrees. But to get to the other side, I have to rotate almost 180 degrees. So if I had modeled this in the middle over here, this twisting would be much smaller. So this was a failure in modeling as well. Like if I really wanted, I could detach this hand and like move it like this and then reattach it, you know. I should probably do this, but I don't want to because I'm lazy. But I do think this is a pretty good example on how rigging like this can work. Like, look at this, looks pretty good, right? The only thing that bothers me is that the way these drivers work in Blender, they're not very efficient. Like if we look over here in the driver editor, it says this is a slow Python expression. So if we use this in Unreal, it would probably be a lot more efficient than this, I would bet. Anyway, that's it for this video. And if you guys try this setup, let me know if it works, or if it's better or worse than the 3-twist-bones setup that people usually do. And yeah, that's it. See you guys later.